Hello everyone, welcome back to my YouTube channel. So for this week, I'm going to explain to you how you should answer quiz 5 questions. So altogether we have 4 different questions and let's start with the first one. Question number 1. Calculate the cell potential of galvanic cell which consists of 2 half reactions shown below. Given in the question is the half reaction for the argentum and also magnesium. You are also given the value of E node for argentum and magnesium. In order for you to answer this question, the first thing that you need to look at is the value of your E node. So, for argentum, the E node is equivalent to positive 0.80 and for magnesium, the E node is equivalent to negative 2.37. So always remember that the more positive the value is, for this case is for argentum, it prone to undergo reduction. So the more positive should be always in cathode. Always remember the red cat. So now we are going to write the half reaction accordingly with annotation of which one should be at the anode and which one should be at the cathode. Alright, let's start with anode. So for anode, oxidation is occurring. So it means that this reaction, this equation need to be swapped. So we are going to start with magnesium and then minus 2 electron to produce magnesium 2 plus. Therefore your E node is equivalent to positive 2.37. So remember, this negative you need to change it to the positive because you have changed the overall reaction. So now we are going to move on to cathode. So cathode, remember red cat, so reduction occurs at cathode. So what you can do is just copy out the thing given to you in the question, whereby your E node shall be equivalent to positive 0.80. So the next thing that you need to do is you need to remember that the amount of electron that plays a role in this reaction should be equal. So since in your anode here you have 2 electrons lingering around, so it means that here you need to have 2 electrons as well. So everything you need to times 2. Therefore, at cathode, you can say that you have 2 argentum plus 2 electron, and then only you get your argentum. So your E node, although you times 2, your E node stays the same, which is 0.80. Right? So now we are going to write the overall reaction for this half reaction. So the overall reaction for the half reaction is, so you just need to write the whole thing here. So you will have your magnesium plus your argentum 2 plus. So you have this one 2 electron positive and negative 2 electrons, so you can slash them out. So you will have magnesium 2 plus 2 argentum. Therefore your E node cell shall be equivalent to just the summation of this, so you should get 3.17. Right, so this is the final answer for the first question. Moving on to question number 2. Calculate the cell potential of the electrolytic cell according to the reaction below. Given that the standard reduction potential for bromine and Fe3+ are positive 1.09 volt and positive 0.77 volt respectively. The way you should approach this question should be slightly different than the one in question number 1. So, in this question, you were given the balance equation here. So from the balance equation, you can at least know which one of these shall go through oxidation and which shall undergo the reduction. So we are going to start with bromine beforehand. So the bromine, so the oxidation number shall be 0, and then it turns into 2 Br negative. So Br negative means -1. So the oxidation number reduces from 0 to -1. So it means that it undergoes reduction. Right. On the other hand, when you have your Fe, so at first it is Fe2 positive and it turns into 2Fe3 positive. Means that the oxidation number is +2 turns into +3. So the oxidation number increases from +2 to +3. So it means that this undergo oxidation process. Right, since you already know which one of these undergoes oxidation and reduction, so we can write the half reaction. So we have anode and also cathode. So remember, for cathode is red cat. So reduction occurs at cathode. So for anode, just now we were saying that it undergoes oxidation. So oxidation, so 2Fe2 plus minus 2 electron shall produce 2Fe3 plus, right? But on the other hand, for the reduction process, so you will have Br2 plus 2 electron, so it forms 2Br minus. So what else that you need to do is you need to add the E note, the value of E note. So given to you, the standard reduction potential for bromine is equivalent to +1.09, but this is standard reduction potential. So since that this undergoes reduction, so you use this value as it is, so 1.09. So for this one, Fe3 positive means that this will undergo reduction to Fe2 positive, but now it's at the anode, so it's the other way around. So since this one is positive 0.77, so it becomes negative 0.77. Right. So from here, what we can do is we can write the overall reaction, which is 2Fe2 plus Br2, because this one is already slashed out, so you will get 2Fe3 plus 2Br negative. Therefore, your E node cell should be equivalent to positive 0.32. So this is the final answer for the second question. Moving on to question number 3. Determine the mass of nickel that shall be electroplated from a solution of nickel 2 chloride by a current of 0.25 amperes flowing for 10 hours, given that the atomic mass of nickel is 58.7. Let's look at the information given to you. The current is 0.25 and is flowing for 10 hours, given that the atomic mass is 58.7. So from here, we know that you can calculate your value of Q. So Q is equivalent to IT. So I is the current, which is 0.25, and T is time in second. So given to you is 10 hours. So 1 hour, 60 minutes, 1 minute, 60 seconds. So it's equivalent to 0.25 times 3.6 times 10 to the power of 4. Therefore, you will get your Q is equivalent to 9.0 times 10 to the power of 3 coulomb per mole. Right. So what else can we do? So you were given that it is from the solution of nickel 2 chloride. So nickel 2 chloride. So from here, you need to know that the thing that is being electroplated is nickel. So you're going to separate this into the ionic form. So nickel, you don't know the charge. So chlorine, definitely you know that it is Cl-. But since you have 2 chlorine here, means that you can predict your nickel should be 2 positive. So why is this so important? Because you need to know how much electron is there in the reaction. So you can write the half reaction, which is nickel 2 positive. So because it will be deposited, so you know that it will turn into just nickel. So it means that it should undergo a reduction process. So plus 2 electron, then only it can produce the nickel. Alright, so I'm just going to quickly recap what we have calculated. So your Q is equivalent to 9.0 times 10 to the power of 3 coulomb per mole. Right, and then we know that your nickel is actually nickel 2 positive, so the half reaction for this is nickel plus 2 electron will produce nickel. So what else that you need to know? So you need to convert this coulomb per mole into Faraday, because then only you can use this half reaction to quantify how much is the nickel that is being electroplated in this reaction. So theoretically 96,500 coulomb should be equivalent to 1 Faraday. So since you only have this much, so 9.0 times 10 to the power of 3 coulomb should be equivalent to 1 over 96,500 times 9.0 times 10 to the power of 3. So in saying that, we should get 9.3264 times 10 to the power of negative 2 Faraday. Right, so how does this get to do with this? How do you relate it? So it means that for each electron, so for each electron is 1 Faraday. So in this case, 2 Faraday will produce 1 mole of nickel. So how much Faraday that we have is this. So we are going to calculate how much mole of nickel shall be produced. Alright, so from here we can calculate the number of nickel that is going to be produced in this reaction is equivalent to 4.6632 times 10 to the power of negative 2 mole of nickel. Right, but if you look closely, the question asks you to calculate the mass. So it doesn't want it to be in the number of mole, but instead you need to convert it to mass. So number of mole is equivalent to mass over RMM. So the number of mole is this one. So the mass is what we are going to calculate, and the RMM, atomic mass, is 58.7. So in saying that, we can get the mass is actually equivalent to the number of mole. So the number of mole times the RMM. So we should get 2.7373 gram. So this is the final answer for this question. Now we are at the final question for quiz 5. So question number 4, how long must a current of 5 ampere be maintained to electroplate 60 gram of calcium from the molten calcium chloride, given that atomic mass of calcium is 40.078? Alright, in order for you to answer this question, the first thing that you need to understand is the source of the electroplating. So we are using the molten calcium chloride. So the molten calcium chloride, right, and then it needs to electroplate the calcium itself. So same drill, you need to divide it into the ionic form. So chlorine Cl negative, since it have 2, so your calcium must be Ca positive. So from there you can write your half reaction. So calcium 2 plus, it undergoes a reduction process, so plus 2 electron shall produce just calcium. Okay, the next thing that we need to do is we need to check what are other information given to you. So in this question it states there the electroplated calcium is 60 gram and the atomic mass is 40.078. So from there you can actually calculate the number of mole. So number of mole is equivalent to mass over RMM. So the mass of calcium that is going to be deposited is actually 60 gram, and the relative molar mass, which is the atomic mass for this case, is 40.078 given in the question. So from there you get the number of mole is equivalent to 1.4971 mole of calcium. Right, so from there you can actually recalculate until you get how long does it take for the current to be flowing so that you can deposit this much of calcium. Alright, so we are now going to write what information that we already have, right? So the half reaction is your Ca2 plus 2 electron will produce 1 mole of calcium. So from this you know that for 1 mole of calcium to be produced, it needed 2 electron, whereby we can change this to 1 mole of calcium needed 2 Faraday. So this is interrelated, right? And then from the previous calculation, the number of mole of calcium from 60 gram is equivalent to 1.4971 mole of calcium. So how much Faraday, right? So it's equivalent to 2 divided by 1 times 1.4971. So you should get equivalent to 2.9942 Faraday. Alright, so what else you can do is you need to convert this Faraday into Coulomb. So you know that 1 Faraday is equivalent to 96,500 Coulomb. So since you have 2.9942 Faraday, so 96,500 times 2.9942. So it is equivalent to 2.8894 times 10 to the power of 5 Coulomb per mole. So again, we need to check on the question. You were asked how long. So how long must a current of 5 ampere be maintained to electroplate 60 gram of calcium, right? So since you already know the value in Coulomb, so it means that you know that this is actually your value of Q. So Q is equivalent to IT. So you can definitely calculate your T, because given to you is the value of I, which is the 5 ampere. So you already know the value of Q. So we are just going to calculate this. Alright, so we are going to calculate the Q is equivalent to IT. So Q is from the calculation you have just calculated, which is 2.8894 times 10 to the power of 5, equivalent to I. Your I is 5 ampere, so 5 times T. So T is actually equivalent to 2.8894 times 10 to the power of 5 divided by 5. So you will get your T is equivalent to 57788. So this is your T. So since you need to convert this T actually this one is in second, so you need to convert it to hours. So it means that 57788 divided by 60 times 60, so should be equivalent to 16 hours. So this is the final answer for the last question. We are now at the end of this week's video, so thank you very much for watching. Stay safe, take care, and see you again next week. Goodbye.